Hello everyone and welcome to Reentry. In this video I will be giving you a brief overview of the Gemini spacecraft. If you've been playing Reentry before, you would typically start your career as an astronaut, or a virtual one, in the Mercury spacecraft. The Mercury spacecraft is more simpler to operate and has a lot of less features and functions compared to Gemini and Apollo. So if you're taking your first steps in re-entry, I would recommend you to familiarize yourself with the Mercury capsule before trying to operate the Gemini craft. The Gemini spacecraft builds upon a lot of the technologies that you've learned in Project Mercury and kind of evolves them in towards the next step in order to kind of meet the requirements and test different technologies for Project Apollo. So first of all, the Gemini spacecraft contains a couple of sections. So if I'm going to open up the manual here, I can press Shift M to open the flight documents, and then I can go into the Gemini familiarization manual, part 1. Part 2 contains the information about the attitude control, platform, inertial guidance, etc. But this one contains all of the other chapters. So this will load up the PDF, and I'm going to reference this a little bit during this video. So let me just get everything positioned correctly. And there we go. So first of all, let's get a brief overview of the Gemini section. So I'm going to also go into external view and then reference page 20 here. So first of all, the Gemini spacecraft contains a few sections. So the main section here is the re-entry module, and you can see that the thing that enters back towards splashdown on Earth is this section here. You can see that's cone, and then this RCS section here. The other sections are jettisoned along the way. So the adapter section, which you can see here, this is the adapter equipment section, contains a lot of various equipment used during a Gemini flight. And then the retrograde section contains the retrograde rockets. There's 4 retrograde rockets which are designed to bring the craft back into the atmosphere for splashdown in the ocean. So these 2 sections are jettisoned before entry. And then you have the rendezvous and recovery section, which is kind of this hat, which slowly will be kind of jettisoned as you progress through the atmosphere and the chutes gets deployed. So the Gemini craft has a few important things to know about. So if I now close this manual and take a quick look at the panels here, you can see that the interior layout of the panels consists of different sections. So you have the commander's panel here, which contains the G accelerator. It has indicators about the launch vehicle fuel state, different lights related to the launch vehicle, and these are mostly used during ascent. And then the G meter is also used during entry. Then you have a couple of controls that allows you to control the attitude indicator, which you can see on the center of the panel. And like Mercury, this has become a ball compared to 3 different needles showing roll, pitch, and yaw. So This wall allows you to much easier understand your reference relative to an inertial platform. You can control the input and operations of this attitude indicator using these switches here. And then it has an altimeter that shows you your current altitude up to 100,000 feet. This is mostly used during ascent and descent. Then you have a quantity indicator, and you have something called IVIs, which is used to show you differences in delta V in forward, aft, left, right, up and down axis. And then you have a rendezvous radar indicator, which is used during rendezvous. And then you have the event timer. And then on the side here, you have different switches to control various systems used on board. I'll get back to some of these later. Then you have the center panel, which contains a lot of information and instrumentation around the oxygen, temperature, pressure, environmental and control system switches, sequencer switches, I'll get back to this soon, radio control, cryogenic control, and a couple of other miscellaneous switches, but it also houses the mission lapse timer, or GT, which you'll be using quite a lot during the mission. This is in order to keep track of time into the mission from liftoff. Down here you have a center pedestal which contains different controls, mostly related to inertial guidance and computer control, but it also has a couple of switches for the sequencer that you'll need to operate during landing. On the pilot side, you have fuel cell control, voltmeter, ammeter for electrical monitoring. You have a similar attitude indicator, which can be programmed individually compared to the other one, so you can have different attitudes showing on the different walls. Then you have a computer and a computer display. So this is the display, and then you have the keyboard over here. And then on the side of the pilot panel, you'll have additional switches to control various onboard systems. And this could be kind of compared to circuit breakers, turning systems on or off, but also moding and selectors. So let's continue with the overview here. So let's bring up the manual again. And now I'm going to cover the sequence system. So basically the different modes or profile of a mission, a typical Gemini mission. So let me just take a look here. So as mentioned, the sequencer contains a lot of kind of sequential steps that you'll need to do. This is also something that was available in the Mercury capsule. So the first thing that you typically do when you reach orbit is to jettison the fairings. These are protective covers used to cover important sensors on the exterior during your ascent. And you would use this one to separate from the launch vehicle once the launch vehicle has cut off and inserted you into orbit. Then the rest of the sequencer lights are typically used for retrograde. So these two are the only two switches that you'll need to use during ascent. These are used during retrograde, and finally these are used during landing. There's also two lights here which are used during landing to signal when to press the drogue and the parachute. So let's take a look at a typical Gemini mission. So first of all, you would have a liftoff, and the Gemini spacecraft ascends into orbit on a Titan launch vehicle, so Titan 2, and it contains of two stages, stage 1 and stage 2. So for the initial part of a Gemini mission, you'll travel above the atmosphere using stage 1. It's ignited with these two engines. Once this one is depleted, you'll be above the atmosphere, and the second stage, stage 2, will take over with its one engine to finalize your journey into orbit. Once you're in orbit, you separate from the spacecraft and you jettison the fairings to allow the inertial systems and horizon scanners to take over. The horizon scanners are used to kind of maintain a stable reference platform for the attitude indicator relative to Earth. So this is a local, vertical, local horizon type of attitude, where prograde will be in the center here at 0. Once you are in orbit, the craft is kind of configured into an orbital mission state using the insertion checklists. So you can hit M on the keyboard to open up the checklists, and you have a lot of the pre-flight steps, which is done here. And then you have the ascent and insertion. And once you've done with all of these, with the exception of the emergency section, you have configured the craft for orbital mission. During this orbital mission, you will do various tasks. A typical Gemini mission contains observation of Earth, maneuvering in space. So unlike the Gemini spacecraft, unlike the Mercury spacecraft, the Gemini spacecraft has the ability to maneuver in multiple axes. So if we take a look at the exterior of the craft, you can see that there's a lot of thrusters and jets located on different locations of the exterior. And these are used to provide you with attitude control. So ensure that the OAMS, it's called the Orbital Attitude Maneuvering System, and this is the primary control system that you do use during your entire orbital mission until re-entry. So I'm going to switch the attitude control to rate command. This allows me to manually now use the joystick. And there's two different joysticks that you'll use to control attitude. So the rate command mode is similar to what you've used in Mercury, which allows you to let the electronics on board control how you get to a given attitude. Direct is a different mode, and pulse is a third manual mode. So first of all, rate command, I'm using OMS because this one is open and the controller is powered. And then you use this joystick here to control attitude, and this joystick here to control translation. So this is the translation hand controller, and this is the rotational hand controller. And they are quite different. The rotational hand controller allows me to fire different jets and have attitude control in orbit. And you can see that the rate command mode, if I now yaw to the side, you can see that it fires the thruster until it reaches a maximum angular rate, and then it stops. And once I release the joysticks stick, it stops at the given attitude when I was releasing the stick. So this allows you to have fine control of attitude movement. Direct allows you to directly kind of cause acceleration. So if I now pitch down, you can see that I fire the pitching, but there's nothing that kind of stops the rate. It just continues. So for every time you do something, you'll produce an acceleration in that direction. And then finally, pulse allows you to pulse the craft briefly to have very fine control of your attitude. Each deflection of this stick will cause a very small pulse, and then you'll need to release the stick and then push it again to cause another pulse. So this can be used to count ticks, or the amount of times you deflect the stick in a direction, to kind of have full and fine attitude control. The other part is translational control, and this is always acceleration, so it's a direct. This allows me to kind of move the spacecraft to the left, to the right, up, down, forward, and aft. And translation control is used to directly modify my trajectory. So if you take a look at my orbit info, if I now, for example, put thrust in the forward direction, you can see that it actually changes the orbit compared to just performing attitude control in the various directions. So this is a very important change from Mercury to Gemini, where you're actually allowed to maneuver in orbit, change your orbital trajectory using these thrusters. So the second system, which will then become active during re-entry, is the RCS jets. This is during re-entry and recovery, and this is used to handle attitude control because the adapter and the retrograde section are then jettisoned before entry, and you'll need to have attitude control to control your entry trajectory. But after you've jettisoned the adapter and the retrograde, you'll have no ways of modifying your trajectory using thrusters because they've been jettisoned. So the thrusters on the entry module has only the capability to change your attitude. So let's continue with this diagram and the sequencer. So on insertion, you've completed these steps, and then during the entry, you'll need to first jettison the adapter. And the adapter is a section that contains the fuel cells, which are being used to power the craft together with some batteries. There's 4 batteries. I'll get back to that soon. And those fuel cells will be jettisoned. So you'll need to ensure that you're into battery mode, so that the cabin won't go dark once you jettison the adapter. Once the adapter is jettisoned, you can fire the retrograde engines at a given time to allow the craft to change its trajectory using 4 quite powerful engines compared to the jets, to fire it in a retrograde direction to bring the trajectory into something that will hit the atmosphere and land in the ocean. Once you fire the retrograde engines, they will also be jettisoned to expose the heat shield, which you'll need to have on during the atmosphere flight in order to protect you from the heat and the friction. Once you're through the atmosphere, the drogue chute will be deployed, and this is a manual step, unlike in Gemini, unlike in Mercury, which it's typically done automatically. In Gemini, you need to press this button manually when this light illuminates. And then you have the main chute, the parachute here, which you'll also need to trigger manually. And then once you have a stable chute and attitude, and you're kind of slowly descending towards the ocean, then you'll need to hit into something called the landing attitude. And this is different from Mercury. This will basically position the craft in a way that makes it kind of act like a boat. You'll hit the ocean sideways, and then you'll float with the windows and your heads pointing up. Compared to Mercury, the Mercury hits the ocean with the heat shield directly down, and it floats kind of like this image here. So that's the basic flight of a Gemini. So Gemini mission. So the mission typically contains different objectives such as orbital maneuvering, different burns to figure out how the craft and kind of orbital maneuvering works, how the orbit is affected by different burns. And then it contains EVA, where you will be stepping out of the craft, and then finally rendezvous with another target satellite, which I'll come back to pretty soon. So I mentioned a couple of things. One of them was fuel cells. So if I go to the fuel cells and electrical kind of overview of this manual, you'll see that the fuel cell sections are located in the adapter module. So the fuel cells, there's 2 fuel cells on board, along with the oxygen and the hydrogen, which are used to kind of generate power in the fuel cells. And then there's water tanks to store water that is produced by this process. So you can think of the fuel cells as a way to generate power. They act like a battery, and their power is generated from the consumption of cryogenic oxygen and hydrogen. And a byproduct of this is water combined with, of course, electricity. So if we take a closer look at the fuel cells, and I'll go to a page containing the fuel cells, you will see that the fuel cells are operated on the main panel here. So you have section 1 and section 2, and then you have A, B, C, and 2A, B, C on each of these sections. So you'll power off on the fuel cells. This is one section, this entire thing. That's you can think of this as fuel cell 1, and then the other one is fuel cell 2. And each of them contains 3 different stacks: stack A, stack B, and stack C, which contains a lot of cells in each stack that produces power. And each of these stacks are individually powered from this 1A, 1B, and 1C switches here, and same for section 2. So the fuel cells are the primary power generator used during the entire Gemini mission, with, of course, exception of entry and landing. During ascent, you have a couple of batteries that can be used, and then, of course, these main batteries, there's 4 of them, are used during the entire entry. So if I now go to kind of the electrical overview here, so you can see that there's the fuel cells here, which is fuel cell 1 and fuel cell 2, and these are operated through these switches and connected to the main bus. So the main bus is the main responsible kind of power bus where most of the equipment on board is receiving power through. There's no direct inverter here. Each of the equipment that requires a DC to AC inverter has this inverter installed directly in the equipment itself. So you don't need to have any AC control in the Gemini capsule compared to what you have in Mercury and even Apollo. So these 2 fuel cells powers the main bus, and you can see that there's some lines coming out of the main bus here. So if I scroll down to the next page here, you can see that these are the ones coming out here. And these are connected to the main battery switches. So there's 4 main batteries. You can see them here. Each of these has an on switch, which allows me to connect the battery online, which means that once it's in the on, there's be a tie between this battery and the main bus. So it's connected directly to the main bus. It also has a test switch. So if I put it in the down position, you can see that it's in test. And this allows me to connect the battery to a tester on here called the battery test, so BT. And this allows me to connect one single battery at a time. So if I switch this back to off, you can see that the battery test is showing minimal voltage. There's no battery connected to the tester. If I put it to test, you can see that I can now individually see the battery level of this battery. But make sure that you never put 2 batteries at the same time into the test position, because that can destroy the batteries. So switch this to off and then test battery 2, off battery 3, etc. In addition to this, there is also Squib batteries. So the Squib batteries are controlled here. You have 3 of them. It's on, off, and then umbilical. During pre-launch operations, before liftoff, these squibs are typically in the umbilical position. And during pre-launch operations, these are put into on to connect the Squib batteries to the various buses. So these are the command control bus, which powers some of the equipment on board, and also the ohms Squib bus number 1 and 2. And the ohms Squib bus number 1 and 2 controls the squibs, which you can individually control here. So the boost insertion or the boost ascent insertion, so BIA, these are used to power the squibs needed to perform staging during boost to insertion, so basically the ascent. And then you have retro 1 and retro 2, which is these different switches used to arm the squibs to separate the and power the jettison of the stages. And then you have the landing for the pyrotechnics for the chutes, and then you have the retro rocket squibs also in full control here. There's 4 retrograde engines on board, and you can control each of them here. But typically you'll arm this during the ascent, and then you'll arm these as needed during entry and retrograde. And of course you'll use all 4 engines during the retrograde burn. Very briefly, I will also kind of cover the let me get the attitude control mode, and this is another thing that I could relate it to attitude control. So previously we talked about pulse, direct, and rate command. You have similar modes for rate command during re-entry, and then you have something called platform. Platform allows the autopilot to take control of the attitude, and now I'm saying that bring the attitude, so my sharp end, forward. You also have a blunt end forward, which is retrograde view. You'll use this during retrograde. Then you have orbital rate, which kind of brings the torque to it, but it's not currently implemented, so you can skip the orb rate here. Then of course you have free, which allows you to use these use a free attitude based on caging. So you can cage the platform. You'll need to do it before going to free, which will zero the attitude on 0, 0, 0. And then you go to free, and it will drift freely from that previous caging. So I'm not going to go too deep into this, because this is an overview section of or lesson of re-entry. Gemini in Reentry. So on board, there's a couple of electrical environmental control systems, and some of them is related to oxygen flow, some of them is related to cooling, and some of them is related to water control. And if we take a look at the oxygen system on board, you'll see that this craft has primary oxygen tanks in the adapter section. These will be jettisoned during or before entry. So this, because this is in the adapter section, and the secondary oxygen supply, which you can control here, you'll switch this to open typically during the mission, and this will allow the secondary system to take over whenever it feels that these the pressure in these is too low. So when the pressure in these gets low, these will take over and provide oxygen to the cabin and the suit loops. So oxygen control is almost fully automatic in Gemini mission, where you have the primary and the secondary oxygen systems. And if we take a look at the different controls for kind of controlling how oxygen flows, you have a couple of these handles which you can pull up and down, which will trigger various functions. For example, if I want to ventilate the cabin, I can use the cabin vent. Snorkel can be used during entry and landing, which allows the cockpit to start breathing air from outside once you've inside of the atmosphere, basically main chute out. You have a cabin recirculation, which allows you to use the fans to recirculate the cabins, etc., and various functions here to kind of have control of how oxygen flows. And you also have the repressurization selector here that allows you to repressurize the cabin in case of pressure loss, or during EVA you'll vent the cabin, and then once you're back inside you'll repressurize the cabin, and this will of course consume oxygen. And oxygen you have visible here, so you have the cryo, so I can switch this selector to O2, which allows me to see the oxygen I have, and then hydrogen, and this shows the quantity and the pressure. And you have another one here which allows you to see the propellant temperature and pressure of the ohms, and then on ring A and ring B of the RCS. So the RCS is, as you recall, the thrusters that you'll use during a re-entry, and this section has two different systems, two rings. One ring can be used for full attitude control, but both are typically used during re-entry for maximum kind of thrust. So when it comes to cooling the craft, so let me change the page. Cooling is typically done through heat exchangers. There's equipment cold plates, there's radiators that the coolant flows through, and there's pumps and coolant reservoirs used to pump the coolant through the systems. So in this craft, the pumps of the coolant system, which you can see on this diagram here, is on and powered. You can see that pump A and pump B of the primary pumps can be controlled here, and pump A and pump B of the secondary loop can be controlled here. Typically in a mission in this version of the Gemini craft, which this manual is based upon, pump A, pump B on the primary system, and pump A and pump B on the secondary system or loops needs to be on for the entire mission. So coolant control is very easy in Gemini. All you have to do is to make sure that all of these pumps are running and that the light indicates that they are running. You also have a radiator, which allows, by the use of this switch, you to select if the coolant should bypass the radiators or flow through them. During pre-launch Earth operations and ascent, you'll need to keep this switch into bypass. This will close the valves that allows the coolant to flow in through the radiators. There's 2 of these radiators. And then once you're in orbit and the spacecraft has cooled down enough for the radiators to cool down the coolant instead of heating it, because they can get quite warm during various forces during ascent. So then you'll need to set this to flow. And there's a radio command that can allow you to ask the ground what the radiator temperature is. So your radiator outlet temperature is good, inlet at 12, set radiator to flow. So that's a quick test that you can use to check if you can switch to flow. And this step is typically part of the insertion checklists that allows you to set the radiator temperature at about half an hour after insertion. So that's cooling. The coolant basically flows through a lot of the equipment around the fuel cells, various cold plates, and cools down the equipment, and then it uses the heat exchangers, the evaporators, and the radiators to cool down the equipment or cool down the coolant before it then goes out back into the loop and cools down the equipment. So the radiator is basically located outside on the retrograde and the equipment section. So of course, once you've going to re-entry, it will need to be bypassed, and the coolant will basically cease to work because these ones are also located. So in the jettisoned equipment, so coolant will be disabled during entry and landing, but that's fine because at that point you'll only have an hour, at maximum half an hour left of the mission. There's a couple of other important things when it comes to Gemini. So this kind of covers a lot of the main parts of the Gemini craft, with exception of this computer. And the computer can be thought of the kind of main interface of how you work with the Gemini craft. So of course you have this manual control, and you have these attitude controls, and you have ways to manually burn. But the computer can give you signals on when to start your burn, but keep in mind that you'll need to do the burn manually with the OAMS system. There is nothing that automatically fires jets when it comes to orbital maneuvering, but you can use this computer for ascent guidance, and you can use the computer for calculating burns, rendezvous, entry help, etc. And the computer is set to on this panel, and the display and keyboard is set to on this here. So if I now switch the computer display to off, and then the computer to off, and I'll go to kind of the pre-launch or the idle program. This, if you've been playing Reentry and you've been playing Apollo, then in Apollo you have a computer program called POO, which is just the idle program, program 0, POO. So this is similar. This is the pre-launch, and you'll need to have it in pre-launch when you start the computer. So then I'll switch the computer to on and turn on the screen. And this will then start to run through various internal checks, and this typically takes 20 seconds. And while it's doing that, I can quickly go up and show you how to control lighting. So there's this selector in here that allows you to control cabin lighting on board of the craft. And then you have an additional light inside the attitude indicator, which allows you to bring light into the attitude indicator here. And then I'll turn this one off just to kind of show you how it looks. And then you also have panel lights. So let me find a switch for that. Here. So I can switch this to white, and you'll see that you'll turn off some lights above the panels. See it like this. And then finally you have F for flashlight. But finally you have the red light, which allows you to have a red light of the panels, which is good for night operations, etc. Anyways, you can see that the self-checks is complete by seeing that it has been cleared all to 0. But if you see that this self-check has lasted over 20 minutes and that the rolling of all of these digits has stopped, but it doesn't reset, you can hit the clear button to reset. And since this is an overview video, I would also like to quickly cover how to use the computer. So first of all, in the checklist, you have a memory core checklist. So if you go back here and you go to the checklists, you can see the OBC onboard computer is very simple. Memory core. You can see that there's a lot of digits in front of various memory addresses. So these are used for various things. So if I now go just verify, I can go to pre-launch and I can hit start on the computer and it runs. Then you can, let's see here, for example, time to AP. So I can go and enter on the keyboard here. You can see that the address here contains 2 digits, and then there's a message with 5 digits. So now, for example, if I go in here and I say 75 and then read out, you can see that the timer shows 4,538, or the message shows 4,538. And if I go to the map, let's see here, and to the perigee, I can hit clear. Always hit clear after you sent an address, and I can say time to PE 76, read out, and you can see that it shows me some number here, and this is the time to perigee, and the previous one was time to apogee. I can also check what my orbital period is by sending address 77 and then read out. And this is the amount of seconds my orbit takes for one full revolution. There's a lot of other things here. I can see my current apogee. So if I go into 98 and hit read out, 1223, which is 122.3. There's no points here, so you just need to know nautical miles. So you can use the computer to monitor various parameters, but you can also use the computers to run these programs. So for example, if I want to run the ascent program, that's typically done before the ascent, I'll hit start and the ascent program starts to run. You also have a catch-up program. This is for now. There's going to be some changes on this soon. This program is loaded on tapes. So all of these programs here. The ascent and pre-launch, and I think re-entry is stored in memory, but the other ones are stored on a tape. And loading one of these programs typically takes 7 to 10 minutes. So once you put this on catch up, you can see that there's this light on the auxiliary tape indicator here, which means that the tape is now running. It means that the computer is now running the tape to load the correct data into its memory to allow you to run that program. And as mentioned, that takes 10 minutes. So let me timescale 10 minutes. Now it's extinguished and the program has loaded. I can now hit start on the computer and it will start to run the catch-up routine. Currently, it will now show a malfunction. The reason for this is that the catch-up program is used to perform burns in orbit, and I didn't give it the correct parameters to perform the burn. So I'll hit reset, and then I can go into checklists, and if I want, I can then go into, for example, the circularized orbit. I've added a bookmark for it here. And this shows you how to use the computer to calculate a burn to circularize an orbit. And let me just quickly show you how it works without actually doing the burn itself. If I go into mission tools, I can request burns, and I want to request an apogee circularization burn. I'll press that button. Mission control will then return to me with the pad. The pad is various data points related to the burn. And if I open up the pad itself, you can see, let's see here, the catch-up maneuver pad. You can see that this pad now contains lines for each of these. So let me get this set up correctly. The first one here is the purpose, and then we have listed the different parameters here. So you can see the GETI has 2 lines with 5 digits, and you can probably see that these numbers here, they're all consisting of 5 digits, and this is equal to the message here. You always have 5 digits. So I can use the autoplot function to automatically type in all the information here into the pad. And then this contains all of the information I need. I've also received this data automatically into the computer by a DCS message. This is an uplink from ground of a data package that will be written into the memory of the computer. So I can acknowledge that I've received it by resetting the light. This light will illuminate every time you receive a package from ground. So you can see that to circulate my orbit, and if I take a look at my orbit now, it's not going to be a very big burn because I'm already in a circular orbit, but you can see that it calculated that I need to thrust 1.2 degrees. Oops, let me, I've been drawing here, clear. Plot again. That will be in the x-axis, that's forward. Which will then bring up the orbit at the correct time. So it estimated that 4 hours into the mission and 54 minutes into the mission, and then 11.4 seconds I'll need to start the burn. Then I can use this catch-up program, and ground has now uplinked all of the correct parameters to perform this burn. So you can see that in core number 1, so let's read that out, 01, it says 454, so that's 4 minutes, 004 minutes, and the last 2 digits are seconds, 54. And then let's clear that and go into number 2. That contains 11.4 seconds. And then you can see that these are the program delta V. You'll need to manually insert that if the uplink isn't available, or if you want to create some arbitrary burns yourself or use an external program. You can see that this one is now set to 1.1. There's some slight rounding issues, so it wouldn't matter if you then used whatever was uplinked compared to 1.2. And then the other ones should be all 0. The 9 in front means that it should be minus. This is also a fractional, so minus 0, which means that there's a 1 here or something, a very small rounding issue. So a 9 here means that it's negative. So if I go to the eraser and I erase away this here, then I'll go and insert a 9 here. If you would see something like this, then 90012 means that it's minus 1.2. So that's a negative direction. So that would be a retrograde burn. Once the parameters has been inserted, this is the predicted output of this burn. If you burn 1.2 seconds at 4 hours into the flight, 54 minutes and 11.4 seconds, then you will reach this orbit. So the parameters has been uplinked. We've been verifying it by checking the memory addresses ourselves. Now, if I hit start here, you see that I don't receive that malfunction light. I now see that the computer is up and running and everything is ready for the burn. Then this one here will then show you what direction to burn. And this is dependent upon your attitude relative to the burn direction. So right now it's a very small one. It shows me that at this time, once the timer reaches 4 hours, etc., I'll need to burn upwards. But that's because I'm not yet in the correct attitude for the burn. But if, for example, I would be looking directly down towards Earth, then upward would be the direction I would need to burn in terms of where I am relative to the burn direction. So the attitude of the spacecraft compared to the burn direction can be continuously monitored using this. And then I mentioned that there's a couple of other things. So let me just go in and open up the flight documents here again. And we're now getting close to the end of this video. The next thing I want to just mention briefly is the docking system. So an important thing of Gemini is docking. There's a docking system that allows us to dock with a target vehicle, and there's an index arm which you can extend using this button. This will bring out an index arm on the front here. You can see it there, which you can use to align with the docking cone of the target satellite. This is the docking adapter. And the docker adapter, let me scroll down quickly to another image, contains this panel here. I actually have a better image. I think it's here. Yeah, this panel is visible in on the target vehicle that you're docking with, which kind of shows you the state of the target vehicle. And the Agena target vehicle, which is the one that you'll be docking with in Gemini, has a couple of lights if it's powered, if your docking is rigid, or if you've been doing docking. It shows you a couple of warning lights in terms of arming engines, pressure. And then you also have the time remaining on the engine, which you can use to do additional burns. So you can actually use the Agena to do a lot of fun things in orbit. And if you go to the checklists here, I can go into Agena commands, and this allows me to use something called the command link. And the command link is something that can only work if you have radar contact and a radar lock on with Agena. And then you can send commands. So for example, if I want to turn on the acquisition lights of Agena, which will make it easy to see from far, then I'll need to send 251, which is on, and then 250, which is off. So 251, then I'll set the outer one to 2, the inner one to 5, and then the other one to the last one to 1. This will not send the transmit signal now because I don't have the encoder powered or connected to Agena, so I don't have radar contact or umbilical contact. But you can use this one to command the Agena to perform various functions such as arming and firing that engine, some attitude control, light control, etc. And then finally, the last thing you would typically do in a Gemini mission is to perform EVAs. And EVAs are typically done by depressurizing the cabin, so you can vent the cabin and you can check the cabin pressure. Once the cabin pressure is 0, you can open up the hatch on either side, and then you can exit the vehicle. And when you've exited the vehicle, you'll have to maneuver around the craft using a special device called the handheld maneuvering system. Here, one was it? Your manual. Just wait for it to load. Five five 655. This is the gun, so you can see that this is then targeted in the direction that you want to translate. So you can use normal attitude control to rotate around, and then you can use translation control to pull yourself forward or aft in the direction that you're looking. So this is kind of a fun device that you can use to travel around. And I recently saw a screenshot on our Discord where someone had been doing an EVA very far away from Gemini and Agena. They used the event timer here to track the time of their EVA. So they started once they exit, and they did a long travel. The Agena Gemini combination was just a small star in the background, and I think that the entire EVA took like 45 minutes before they returned inside. Keep in mind that this fuel level on this is very low, but there's an additional backpack located in the rear of the spacecraft that you can pick up, which will give you 60 seconds of additional fuel. But remember that you don't need a lot of fuel to maneuver around, as long as you maneuver correctly and kind of behaved. But anyways, that was a good overview of the main things that you will be seeing in the Gemini craft. I wanted to make this video kind of in-depth just to help you get started with Gemini, but keep in mind that the Academy lessons will give you the same overview and go much deeper into each of these systems that I've briefly mentioned today. So with that in mind, I'll hope that this will help you. Please like, subscribe, and leave a comment if you like me to create videos like this, and have a fun time in Reentry. So thanks for playing.